Hey, welcome back, students. In this problem, we're going to go ahead and solve another Dalton's problem. However, we've got a slightly different scenario here. What we've got is we've got a container. It's got three gases in it, and we're looking for a partial pressure. And so let's read the problem. The problem reads, what is the partial pressure of carbon dioxide in a container that holds 5 moles of carbon dioxide, 3 moles of nitrogen, and 1 mole of hydrogen? And it has a total pressure of 1.05 atmospheres. So essentially what we've got is this. So we've got one container here, and in this container we're going to have CO2, we're going to have nitrogen, which is N2, and we're also going to have hydrogen, which is H2. And all of these gases are in here, and each of them are under different pressures because they have different volumes, right? And so essentially what we need to do here is kind of figure out a way that we can come up with this answer. Well, let me give you the equation, okay? In order for us to solve this problem, which is the partial pressure of some element or some gas, is we're just going to put X. The partial pressure of X is going to be equal to the mole ratio of X multiplied by the total pressure. Okay, so this is the way we solve this particular problem, and what we need to do is kind of fill in the numbers and make sure we got the right answer. So if we're looking for the partial pressure of X, in this particular case, it's asking us to find the partial pressure of carbon dioxide. So this here is your P of X, which we're just going to go ahead and write as P of CO2. Okay, and then the mole ratio. Well, in order for us to find the mole ratio, what is a mole ratio? We keep in mind that a mole ratio is essentially going to be a part divided by the whole. So the part that we know here is going to be the part for CO2. So CO2 holds a total of 5 moles of CO2, and the whole, what is the total number of moles for this container? That's going to be 5 plus 3 plus 1, so that's a total of 9. So there are a total of 9 moles total in this container. So this is our mole ratio, which is 5 to 9. And so when we write this problem, then we're going to go ahead and write P of X, which is P of CO2, because that's what we're trying to find, is equal to 5, 9, okay? And we don't put the moles because the moles cancel. And then we're going to multiply this by the total pressure. In this particular case is 1.05 atmospheres. And when we do this multiplication, we take 5 divided by 9, then multiply that answer by 1.05. That'll give us a specific number. Let me just show you what you get. If we take 5 divided by 9, we actually get 0.555, and we multiply this by 1.05 atmospheres. Our final answer should be 0.583 atmospheres. This here is the answer to this problem. So just keep in mind that when you're trying to do this, equations are very important, and the important equation for us is this one here that I've identified in white. Partial pressure is equal to the mole ratio times the total pressure. This is slightly different than the equation that I showed you before, where the partial pressure is equal to the total pressure is going to be equal to the sum of all the pressures. Okay? And the reason we're using this is because it's a mole ratio. It's only a fraction of the total pressure involved.